Hello everyone, today I'll talk about creating an on-the-fly MCI path. I'll start out by showing you how to download the relevant software. To begin, we're going to download Inkscape, which is an open source free imaging software. You can find it by searching Google for Inkscape. Next, we're going to download G-code tools for Inkscape. It's shown here. You can find it by searching for G-code tools on Google. The installation instructions are shown here. Next, open up Inkscape. We'll start with a blank document. I'm going to add some text here. Now I'm going to convert this text into a path by going to the path menu and setting it as a path. Then I'm going to go to the extension for G-code tools. Go to the engraving option, and here you can select where the output G-code will go. Make sure you go to the engraving option before you do it, or else it won't work. Once you see that green box, it means the G-code's been created. Here I open the file that's been created, and it shows you the G-code generating that path that we made in Inkscape. For creating an MCI path, all we're interested in is the XY coordinates. So the header files and the foot files can all be deleted. Here I'm going to format the text to be how I would like it. And as I said, I'm only interested in the X and Y coordinates. I don't care about the G-code commands or the letter X or Y itself. You'll see I use a file.io C script, and all it is interested in is double numbers separated by a space. So I'm going to remove all things related to feed rate and all things related to the z-axis, because we only are interested in X and Y coordinates, the XY commands for the galvos themselves. For the on-the-fly application, every axis is independent, so you have one linear axis and two galvos. Separate commands need to be sent to each axis. So the XY commands for the galvos come from these coordinates here. Now I'm going to open that formatted text in Excel. Make sure you go to the delimited option, and it's separated by a space. Delete that first column, it's not necessary. And there's space in here, we don't want those spaces. However, those spaces tell us the beginning and end points of the letters. So here I'm going to add -1 to turn the laser on, and -2 to turn it off. In the C script I've written, if I detect a -1 for both the XY coordinates, then I know to turn the laser on, and if there's a -2, I know to turn the laser off. Okay, just about done with that. And next I want to create the commands for the linear motor. So here I have the commands for the galvos, and I want the linear motor to go between the lowest y-axis value, which is roughly here 180 or 190. And I want to go to increase up to the maximum value, which as shown here is roughly $240. So I'm going to increment by 240 minus 190 divided by the number of numbers we have, which here is 233. So that gives us a value shown here. And I'm going to start at 190 and then add this increment value, 0.2146. And I'm going to fill down so that it adds 0.2146 to the previous value. That way I have a linearly increasing command for the linear motor. We'll have a constant velocity in one direction. Now I'm interested in maybe the difference in the linear command and the galvo y command, and that's going to tell me how much deviation that galvo is going to have. And we don't want that deviation ever to be larger than the field of view of the galvos. So here I'm printing the maximum value of this deviation. And you see there's large numbers because of the special formatting I did with the -1s and -2s. So if I remove those values, you'll see that the maximum deviation is within 20 centimeters, which is about the field of view. That's acceptable. So the way the on-the-fly works is the commands for the galvo is basically the deviation between the command to the galvo and the linear motor. Now I'm going to upload the file using WinSCP, which can be downloaded for free online as well. So you log into the controller similar to PuTTY, and you upload this file. So here I'll save the file as a text file. I forgot to format it properly, so all I want is the X, Y, Z coordinates. X, galvo Y, and the Z is the linear motor. So now that it's saved as a text file, I'm going to upload it. So I find the text file, and I hit the upload button, and we want to upload it to the root of the controller, which it should open to on default. So that's okay. Okay, so now it's uploaded. I'll double check that it's on the controller now. There it is. So now that the file's on the controller, we can read it using a script. So I'm going to log into the QTCreator Linux environment. So here it is. And here you can see the file I have written to read the script I have to read the file I just saved. This file is available. Just ask me and I will send it over to you. The file should be run inside a worker thread, so I'll just send you the script and you should copy and paste it in the worker thread. That is standard on GUI scripts. So now I'm going to open Motion Tools to the controller that I've uploaded the file to. And I'm going to push the environment onto it. And I have the function written in function B. So as soon as I call function B, it'll look to the file. It'll read the script, and it will open the file, read the file, and send the commands there to the relevant axes. So when I press B, you can see here in the X, Y scope that it's going to be writing out the text that I told it to. That text said test, and here you can see it, because I had the test start in the positive coordinate quadrant, that it starts with the bottom letter. Now I'll show you an image of what that would look like if I had sped it up and played it, and recorded all the points. So here you can see it says test pretty clearly. You can see the motion between the letters. Now I'm going to show you the YT scope, so you can see that the PCOM on the linearly increases, and you can also see how the galvo Y position stays near that linear motor. So the true galvo position is a deviation between the pink line and the green line shown here. So the green line is just linearly moving between 2 points, and the pink line is writing out the letters. And that's it for sending a path to on the fly using an MCI.